Alright, let's do some coding with respect to natural language processing and recurrent neural nets. What will we do? Well, we will look at an example of an embedding layer, yeah? And we will look at an example of transfer learning. So in transfer learning, what we're going to do is we're going to use pre-trained embeddings of GloVe in order to work with a smaller data set. And it's a bit similar than what we did with COVNets. We will actually not use a small data set. I do this mainly to show you how it is done. And then of course we'll look at recurrent neural nets, what we call a simple RNN, and we will look at LSTM. Yeah? So these are the 4 exercises that we will do. The data set we're going to use is IMDb. Yeah? Remember, this is the Internet Movie Database, and we've used that before, yeah, many times. So I have the scores of naive Bayes, logistic regression, random forest, gradient boosting machines, and a dense neural net. And we're going to add these 4 to it. Yeah? Word embeddings, transfer learning, simple RNN, and LSTM. Alright, in Keras, we have a layer called the embedding layer. Yeah? What does an embedding layer do? Well, basically, the embedding layer is learning your word embeddings. Yeah? So as an input, you have your maximum word index. In our case, it's 7,500 most frequently used words in the English language. And we have the sequence length. So the sequence length means how many words we take in per review. And we're actually going to take the first 150 words of the review. And then the embedding layer, you have to see that it maps this an integer word index basically to a dense vector. Yeah? So here we have 2-dimensional tensor integers. Yeah? So each of these 7,500 words has an index, and that's an integer between 0 and 7,500. And at the output, we get the same, but we have an embedding dimension. Yeah. So this is something we need to give to the system, because at the output you have a 3D floating point tensor. Yeah. No more integers. And these are your embeddings. Yeah. So see this embedding as sort of a dictionary where you have words and indices that are going to be converted into embedding vectors here of length 8. Alright, so transfer learning we will look at as well. We take the base of GloVe, and the GloVe base has been trained on 1 billion of tokens. The vocabulary will be 400,000 words, and in terms of embedding dimensions, so this number, we have choices, 50, 100, 200, 300, and we decided to take 50. Yeah. Then there is another type of layer in Keras called the recurrent layer. This will be written as simple RNN. Yeah. And whatever we use at the input of our model, we need to specify the batch size as an argument. And we have a Boolean parameter here that if return sequences is false, that means that we only look at the last timestamp. If it is true, you will get the results at every timestamp. And then at the end we have another layer, LSTM, and also takes as an argument the batch size, in our case 32. Alright, so let's take a look at it and see what the results are.